Alright, so in this video I am going to show you how to solve a first order linear differential equation using an integrating factor. This is a homogeneous equation, which means that the equation is equal to 0, and they're a little bit easier to solve. They're a little bit quicker than non-homogeneous equations. So what you want to do is you get their differential equation standard form, which is this. You have your derivative by itself, isolated. All right, y prime plus p of x y is equal to q of x. You don't really have to worry about the q of x very much for homogeneous equations, but this is the standard form for a differential equation when you want to solve it using an integrating factor. Now, what an integrating factor is essentially is just e raised to the integral p of x dx. Now, for this problem, our p of x is tangent 5x. So we just evaluate that. E to the integral tangent 5x dx. Now tangent's kind of a funky integral because you can write the same solution two different ways. You can either do, if it's just tangent x, you can do the negative natural log of cosine x, or you can do natural log, the positive natural log of secant 5x, or secant x. I'm going to work with secant just because that's how I always do it. So this is equal to e raised to 1 over 5, because it's 5x, times the natural log, the absolute value secant 5x plus c. Now, whenever you have a homogeneous equation, meaning, as I said earlier, the equation is equal to 0, you can find the standard form for the solution of the equation using just this. So our standard form is going to be, we can bring the c down because it's e raised to a natural log. So it becomes c, well, plus c. Yeah, c e to the 1 over 5 natural log of secant 5x. And because it's a natural log, the e in the natural log cancel because natural log is already base e. So this is just equal to c. And this part right here, the 1 over 5 in the front, you really want to pay attention to this because this goes into the exponent of whatever is inside your natural log whenever e is raised to the natural log of some function. Now that you might have gotten lost in the words of what I just said, so I'm gonna show you what I mean. If it is not a fraction, if it is a whole number multiplied by the natural log, then that goes to the exponent of what's inside of the natural log function. If it's a rational function, or a rational number multiplied by the natural log of some function, it becomes a negative exponent. So this goes into the denominator. But I'm going to write out what I mean. It becomes c times, why is that not working? becomes c times secant 5x to the negative 5. Or you can write it, just put it in the denominator like I said. So that is the solution to your differential equation. Y is equal to c divided by secant 5x raised to the 5th, or c times secant 5x to the negative 5. If you have some kind of initial condition, like, let's say your question said y of 0 is equal to, we'll say 7, then you want to set y equal to 7 and x equal to 0. So after you find your solution to that particular differential equation, you want to solve for c based on the initial condition and the solution you found. So we're going to get y. No, not y. I apologize. You're going to get 7 is equal to c let's do it like this. C times secant 5x, so we'll say 0 to the negative 5. Secant of 0 is equal to 1. And 1 to the 5th is still equal to 1. So 7 is equal to, I'm going to use this form again. I apologize for swapping between forms. Which is equal to c over 1, which means that c is equal to 7. So we plug in c and we get y is equal to 7 divided by secant 5x to the 5th. And that is our solution for that differential equation with the initial condition y of 0 is equal to 7.